The other thing I want to suggest that you do is that on the Zoom, that on my picture, pin me to the board. You're going to want to see me bigger than anybody else. Now, I know when I'm talking, you should be seeing me, but if you don't want to switching to other people, you could do it by just pinning, going on those three little dots on the side, clicking on it and press pin on my picture, and then I will be the one that you will see. If any of you had gone on to the Blackboard, and obviously some of you have, what you will see is that aside from having things on Blackboard, what I'm going to ask you to do is to sign up for something called Delta Math. Let me write this on the board. You'll just go to deltamath.com. And what it's going to ask you for is it's going to ask you for a class code. It's posted on Blackboard, but I'll write it here also. It's 2U5-Z6EJ. And you will see when you put in that class code, it will come up as Professor Weinberger's Math 136006 class. That is us. And you will be able to find homework there. There will even be homework assigned after today's class. The homework, you'll see it's very interactive. In other words, you get to do problems. If you want to do more problems, you can do more problems of the same kind. And basically, it'll be examples that will reflect what we have covered in class. As we go over things. Also, as I said, so that's one of the important, that really one of your first assignments is going to be to sign up for Delta Math. And I think I will even have signed some examples for you to try on it for next week. Just as a reminder, we meet on Monday, Wednesday, and Friday from 8:20 to 10 a.m. So I know it's an early class. You're going to have to get up early. Hopefully you'll be on time. What I usually do is I certainly try to be here by 8 o'clock at the latest. Certainly, if you want to speak with me on an individual basis, sign on a little bit earlier. Or if you have anything else that you'd like to speak to me about at some other time, you can always send me an email. You notice I'm sure you've gotten it. My email address is p.weinberger at mec.cuny.edu. And I check those emails a couple of times a day, and I can't say I'm checking them every minute, but if you have something that you want to tell me, then you certainly can let me know. Aside from that, there is a book that is a textbook that is assigned to this course. It looks like this. It's called Intermediate Algebra, and McKeague is the author. I am not making it a requirement, but if you like a text, first of all, it's not expensive. So if you like a text, then it's a good source. This is the book that's assigned for the course. So therefore, it's basically going to be in step with the things that I am teaching. So if you like to sit down and read and review and do extra problems, then this book is a good source. Again, I'll post it on the Blackboard website if anybody wants to get it. Again, I'm not requiring you this term to buy it. If you already have it from some other source, then it's a good additional source. As I said, our homework is basically going to be done on Delta Math. Now, there will be occasions where there'll be something that is not covered properly in Delta Math, and I'd like you to do additional homework. And in that case, I will post it on Blackboard, and you will be able to access it on Blackboard. Aside from that, I don't know if there's anything else anybody would like to ask me. Does anybody have any questions before I go any further? Okay. I can't emphasize enough. Okay, so as I said, the book you do not need to get unless you really want to, and you can get it at any time. So it's not, again, if the earlier you have it, the more it's good resource. But again, you must get on to sign up to Delta Math right away. That not during class, but as soon as after class as you can, because that you'll see is going to be your source of homework. And it gives you examples, and keep getting different examples. So every person is going to really have a different example to do, but basically it's going to give you examples and show you how to do those examples. If you have a problem, then you can click on either there'll be a little video or something to help you navigate. I am going to start this course with solving basic equations. I think most people know how to do it, but we're going to do some problems today in class. You might have, if you went on Blackboard, you might have seen that I also, in the what's called the weekly classes, that section, which is what I asked you to look at, you'll see it says homework for 136. There was a page. I'm going to be using examples from that page today. So if you have that handy, fine. If not, I'll put them on the board. I just wanted to mention, if I did post the academic calendar, and I noticed that we have classes today, Monday and Wednesday, next Friday, and the following Monday there are no classes because of the Labor Day weekend. And then we'll resume, so there will be a little bit of a break. I'll remind you of that again. I will, each morning before class, send out a reminder. I hope you won't mind getting so many emails from me, but I'll send you a reminder about class, just so that it's easy to forget when you don't have to actually physically leave your home, but you have to be here in class anyhow. as I said, I will sign in as close to 8 o'clock, sometimes even a little before 8 o'clock. Class starts promptly at 8:20. I know I started a little bit late today, but it's the first day. But we are going to be starting promptly. Again, if there aren't any other questions, then I'm going to put a problem on the board and give you a few minutes to try it, and then we'll go on from there. Okay. By the way, I saw somebody just signed out in with, it says iPhone. I do keep track of attendance, and I very often do it by just looking at who the participants are. So I would appreciate, you don't have to change it for now. The person who's on iPhone, if you want to send me a private chat to tell me who you are, that would be good. But please try next time to come on with your name. Again, it's just also a security measure. I don't want to have just anybody signing in. I am not at this point requiring that you be in a waiting room. As I said, there's just a code to get into the class, the Zoom class. But if there's any interference, then we may have to do more security. But right now, we're going to leave it like this. Okay. Well, here's a problem. Okay, we're going to start with solving, first of all, the most basic type of equation. Suppose I gave you 7x minus 5 equals 30. Okay, I'd like everybody to try that. And then when you come up with an answer, you can put it on the chat. Okay, I see most people have sent me a message, and everybody that sent me the message sent me the answer 5. I'm just going to do it for those, just as a reminder how to do it, and just that is the correct answer. Okay, so remember when we have a equation, what we want to do is end up with all the variables, the x on one side, and we want to end up with all the numbers on the other side. So in this case, since the x's are on the left side, we want to get the 5 to the other side because it has no x. And we always do the what's called the opposite or inverse operation. We do just the opposite of what we see. I see a -5, so I'm going to do the opposite, and I'm going to do +5 to both sides, which will give us, this will cancel this out, 7x equaling 35. And once we have all the x's on one side, all the numbers on the other side, then we divide by the number, the coefficient of the number of the x, which in this case is 7. And whatever we do to one side, we do to the other side. And of course, 7x divided by 7 gives me x. And 35 divided by 7 gives me 5. So my final answer, the value that we're getting for x is 5. What does it mean that 5 is the answer here? When we start with an equation, we're starting out with a statement of two things of truth. It's true that we have 7 times something. When we subtract 5 from it, we're going to get 30. We are looking for a value to fit into the x that'll make this statement true. Obviously, when we find x to be 5, 7 times 5 would give us 35. 35 minus 5 equals 30. To say that x is that 5 is the solution of the equation is equivalent to saying we have that when we use 5 in place of x, we're getting a true statement. If I would use any other number in place of x, it would not give me a true statement. So that's what we're looking for. We want to make sure that what our original statement that we're putting in is giving us a true statement. Okay, is there anybody who has a question about how to do this before I give you one that's a little bit tougher? Okay, I was glad to see that everybody was able to do that. Okay, so here's our next problem. Okay. We're going to have 10y plus 3 equaling 3y plus 17. Okay. So what's different about this, and again, we want to solve this, is we don't have our variable just on one side. We have variables on both sides. We have a variable and number over here, a variable and a number over here. Okay, I'm going to give you, again, a few minutes to try this example and make sure you can do it. Okay. I'll give you a couple more minutes. I see some people are still haven't responded. Okay, I think we can try this now. As I see it, a bunch of people did give me the answer too. Let's make sure that that is the correct answer. And let's go through this problem. Okay, so again, for those of you, as I said, most of this is just review, but I'm going through it thoroughly because just as a reminder for some people who are a little bit, if you haven't taken a math course in a while, it might take a little bit of time to get used to it. So let's look at this equation. Again, we have a statement where we have the y, we don't know what it is, but we're looking for a value of y that will make this a true statement, okay? And what we want to do is make sure, again, to get all the variables to one side, and I usually like to get them to the left side, though it's not necessary on an equation, and all the numbers, those that are not attached to a variable, to the other side. And I usually try to work on the variable first, though there's no reason that it has to be that way. It's just my standard way of doing it. So if I want to get all the y's to the left side, I want to then get rid of this 3y that's on the right side. And the way to get rid of the 3y is, again, when there's no sign in front of something, it means it's positive. We want to do the opposite operation. So we're going to do minus 3y. And I'm going to have to put the minus 3y under the 10y, because I can only combine what are called like terms. And like terms are something that has a variable has to have a variable. Something that doesn't have a variable, and that's just what we call a constant, will not be a like term to that. I could not combine these two things, but these are like terms. Now, when I do 10y and add a negative 3y, or subtract 3y, 10y minus 3y, I'm going to get 7y. The 3 I haven't done anything with, so I just bring it down. The 3y minus the 3y cancel out, and that leaves me just 17 on this side. Now I'm sort of back to the place where it was with the previous example. I have all the variables on one side. I just have the 7y on this side. What I want to do is get this 3 to the other side. So I'm going to minus 3 from both sides. This will give me 7y equals 14. The 17 minus 3 is 14. And again, as we did before, we divide by the coefficient, the number in front of the y, and our final answer comes out to y equals 2, which is what people did send me as the answer. Yes, y equals 2 is the correct answer. What I do want to mention is that if you want, you can check your answer, take the 2 and put it back into the original equation. I'm not going to require you to check, but if you want to check, what you do is you take your final answer, your y equal to 2, and you replace the y in the original equation with 2. That will give us 10 times 2, because in place of y, I'm putting 2, plus 3, just put it like this, equals 3 times 2. Again, I'm replacing the y with 2 plus 17. And in the top, I'm going to get 10 times 2, which is going to give me 20 plus 3, which is 23 for the left side. Just move back a little bit. And on the right side, I'm going to get 3 times 2, which is 6 plus 17, which is also 23. And when you get the exact, it doesn't matter what number you get, as long as you get the exact same number on both sides, that constitutes a check. This does the make when I have the answer y equals 2, it means that we have found a value for y that will make this a true statement. Again, any other number will not make it true. Okay. Are we ready to go to something that's a little bit a drop? Again, I'm going to the next stage. I'm now going to do an equation that has parentheses in it. Okay, so let's try one like that. Okay, so what if we have this problem? 5 parentheses y plus 2 minus 4 parentheses y plus 1 equals 3. Okay, again, I'm going to give you a few minutes to try this out. Okay, see a couple of answers coming in and they all look correct so far. Giving people a little bit more time. Okay. So I see a lot of people got -3 as the answer. Let's make sure that is the right answer. And again, let's go through the steps carefully so that we make sure we're doing this correctly. So when we have a parentheses in our equation, what we want to make sure is to get rid of those parentheses. And the way we do it is by taking the number that's immediately in front of the parentheses and multiplying it by everything inside the parentheses. It's called using the distributive property. We're going to distribute the number on the outside to each of the numbers on the inside. So where I see this 5, parentheses y plus 2, I'm going to do 5 times y, which of course is going to give me 5y. And then I'm going to do 5 plus times 2, which is going to give me positive 10. Remember, a positive times a positive, of course, always gives you a positive answer. Then we go on to the next. That takes care of our first parentheses. Looking at our second parentheses, in front of that second parentheses, we have a 4. And in front of the 4, there's a minus. Now, that minus obviously can be used as subtraction. But in this case, since we're doing multiplication before we're doing the subtraction, let's include as part of the number this sign in front of it. In other words, in order to get rid of my second parentheses, I'm going to multiply everything by -4, because that minus can be looked as in 2 ways, as either a subtraction or as a negative sign. But when we're dealing with parentheses, we'd like to use it as a negative sign. So we're going to do -4 times y, which will give me -4y. And -4 times +1, and the negative and a times a positive is negative, is going to give me -4. And that's going to give me equal to 3. Be very careful when you're multiplying and when you're adding and subtracting to be very cautious with those signs. Okay, now we have a bunch of stuff on the left side. We only have one number on the right side. That's easy. But on the left side, we have 4 terms. And what we want to do is combine the like terms, gather the terms that have this y's together and gather just the plain numbers together. So what we have here is a positive 5y minus 4y. I'm looking just at the terms that have y. So when I combine 5y minus 4y, don't forget 5 minus 4 is 1, so I'm getting 1y, which you could write either as 1 with a y, but usually we just write it plain y. When we write a letter, a variable without any number in front of it, it's understood that its coefficient, the number in front of it, is understood to be 1. So that takes care of our variables. Let's take care of the numbers now, the constants. There's a positive 10 minus 4. Well, 10 minus 4 is positive 6. So this becomes y plus 6 equals 3. Things are getting much simpler now. That's the whole point of this method of solving equations, is to get things down to the final step where you have only variables, one variable on one side and one number on the other side. So we're going to get the 6 to the other side. It's a positive 6, so we're going to be minusing 6 from both sides. This will give me y alone on the left side. 3 minus 6 is -3. Remember, if you a +3 and a -6 combined to a -3. Notice this is the end because there's the coefficient in front of the y is understood to be 1. We have what y is. So y equals -3, and that's what everybody was showing me. Let me just stop for a second here and make a comment. The numbers we've been using here have been relatively easy. We have not really touched upon large numbers or decimals or even fractions. But of course, that's coming. And in real life, not everything works out to be perfect numbers like 1, 2, and 3. Usually their numbers work out. If you're really doing the problem, if you're going to the store and trying to figure things out, it's not coming out to be those nice, simple, easy numbers. So how do we deal with those more difficult numbers? Well, obviously you can do it by hand. That's a possibility. And you really should know how to do that. But really, when you have more difficult numbers, one way of dealing with it is to use a calculator. And a calculator is actually a requirement for this class. Now, it's not required for the first couple of lessons because most of what we're going to be doing is going to be relatively easy calculations. But we are going to have cases where the calculations are going to be much more difficult. And then there are going to be things that we're going to have to know how to do on a calculator because that's the only way we'll be able to access them. In other words, when we're going to be doing things with trigonometry, we're going to need a calculator. When we're going to be doing things with logarithms, we're going to need a calculator. When we're going to be doing things with square roots and cube roots, we're going to need a calculator. So at this point, you should be getting a 2-line scientific calculation. And now is the time that you should be buying it. If you don't have one already, now's the time that you want to buy it because right now school supplies are on sale. And if you go to a place like Staples, I don't have any stock in Staples, so you don't have to go to Staples if you don't want. It's just a source. Staples or Walmart or anything, you'll probably find a 2-line scientific calculator that's relatively inexpensive. You really should not be having to pay more than $20 is a lot. You can $20 or less. Now, as I said, I'm not requiring you to buy the book. If you want to get the book, it's a good idea to have it, but it's not a must. But what is a must is this scientific calculator, because you can't do the course without it. And you want to get used to using it as quickly as possible. Again, let me just mention, what does it mean that it's a 2-line scientific calculators? What you're going to see on your screen, and it could be really, the only thing you're not allowed to get here is a graphing calculator. That's not, I can't say it's not, you're not supposed to be using this in that in this course. You want a scientific calculator. And what it'll look like is, I mean, here are all your buttons, right? And here's your screen. Now you're going to push some buttons, and let's say you push 1 + 5, let's say. And then you press your equal button. And the answer will come up on the next line. You'll be able to see your original problem. And then when you press equal, it'll give you the answer. It's a very big advantage. the one line, the very, very cheap calculators only have one line. And as soon as you press the equal button or enter button, your original information disappears. All you're left with is the answer. Very good to be able to check that you put in the problem correctly. That's one of the advantages of a two-line calculator. But there's another advantage of the two-line calculator. First of all, the two-line calculators, scientific calculators, always have a button that will look something like this. It doesn't, again, depending on the company, it may look a little bit different. That is the button that allows you to put in a negative sign. Now, in a regular one-line calculator, you might not have that. So, and you must have this. You must be able to put in negative numbers. Number two, what the calculator does, and this is probably the most important thing about a two-line calculator, is that it does things in correct algebraic format. It follows the rules of combining like terms and doing things in the correct order of operations. It's all built into the calculator. So if you'll put in something, and you'll even be able to put in things with parentheses in these two-line calculators. If you just want to check your answers, you just put in the numbers exactly the way you see it. It's direct, what's called direct algebra logic, and it'll do things in the correct order. You won't have to tell it to first multiply and then add. They'll know that. Whereas in the one-line calculators, if you don't put things in the correct order, you're going to get the wrong answer. So for all of these reasons, I know I stopped and I talked about it. You want to get a two-line scientific calculator. Now, if for some reason you buy a calculator, you're not sure if it's a good calculator, you just show it to me. Either you can send me a picture, and email me a picture, and I'll tell you if it's good. Do not open the package if you're not sure it's correct, because if you don't open the package and it's not the good right calculator, then you can return it and exchange it for something that is. There are many of them. There are some very good ones out there. I'm not requiring you to get a specific one, but you must have a calculator for this course. Okay, now let's go back to another problem. This is actually off. Okay, then somebody has a raised hand. You want to ask me a question?
Yes, I was going to ask you, the calculator I have, is it the right calculator? Let me try to open my screen.
Okay, either show to me on your, can you show me a picture, open up your, by the way, you want to tell me what your name is?
Hi, my name is Rugena Pierre.
Okay, Pierre. Pierre is your name. Okay, let me
Yes.
Okay. Okay, now let's see if I can find you. Okay. Oh, so what you have is a graphing calculator. Now that which happens to be a great calculator, but you're really not supposed to be using that for this course. You need a calculator.
Okay.
I certainly keep that calculator because it's a good calculator, but it's a little bit too advanced. They really don't want you to have something that advanced.
Okay.
Okay. All right, here's our next problem. I'm actually taking it off this sheet that said homework on it. Okay, here it is. It's a really hard one. 3 parentheses 2x minus 1 minus parentheses 4x plus 3 equals 5x minus parentheses 7x plus 1. I mean, we've really gone a long way. So let's see if we can do that one. See if we can get that one done. Yeah, this is getting harder. It could be a couple more minutes. It's a long problem. I see some people have come up with good answers. Okay, I think let's try and do it together. I saw a lot of people did come up with the right answers. There were a couple of answers that were not completely correct. So let's go through this very carefully for those of you having a little bit more trouble. Again, the first thing we want to do is remove any parentheses that we see. And I see this parentheses 3 parentheses 2x minus 1 means I have to distribute the 3 times each of these. So 3 times 2x is 6x, and 3 times negative 1 is negative 3. That takes care of our first parentheses. And now we come to our second parentheses, except there's no number in front of the parentheses. It's just a minus sign. But if you recall, when there's no number in front of a variable, it's understood as the number is 1. That's true about a parentheses as well. If there's no number directly in front of the parentheses, there's just a plus or a minus, it's as if there is a 1 there. So there's an imaginary 1 sitting there. They don't put in the 1. It's understood to be 1. So this tells us that what we have to do is take every term in the second parentheses and multiply it by negative 1. So negative 1 times 4x is negative 4x. And negative 1 times 3 is negative 3. it's essentially what you're doing when you have a negative in front of a parentheses is changing the sign of every term in the parentheses. Notice we now on this left side have no parentheses left. Let's go to our right side. So the first thing we see is a 5x. And again, we have this situation where we have a parentheses with no number in front of it, just a minus. Again, we're going to put in, again, you don't have to actually write it in, but remember, it's as if there's a 1 there. And we're going to multiply everything in that second parentheses by -1. So we're going to get -7x and -1. So already the situation looks much simpler because there are none of those parentheses. Now we're going to go back to our left side and we're going to combine all the like terms. So first I look at the x's. I have a 6x here and a -4x here. 6x minus 4x combines to 2x. Then I look at the numbers. There's a -3, a -3 here, and a -3 here. Now be careful, when you add a -3 and a -3, what you're getting is -6. If you put it in your calculator, you'd have to push your negative button, -3 minus 3, you'll get -6. So if you have trouble with what's called sign numbers or integers, you can always do it on your scientific calculator. Let's go to our right side. Combine the like terms, we have a 5x minus 7x. Now 5 minus 7 is -2. So this is -2x minus 1. Okay, so now we have everything simplified on each side. We're now going to our last few steps. We want to get all the x's to the left and all the numbers to the right. So I want to first get rid of this -2x. So I'm going to do plus 2x to both sides. And the 2x plus the 2x will give us 4x. Just bring down that -6. And now the -2x and the positive 2x, those are canceled out. So the only thing I'm left with on my right is -1. I then want to get rid of this -6. So I'm going to add 6 to both sides, which will give me 4x. This is no longer here. -1 plus 6 is 5. And then I'm going to divide both sides by 4 to get my final answer. X equals 5/4, which is what most people did give me as the correct answer. It is the correct answer. If you wanted to given it as a decimal, your answer, if you put it in your calculator, 5 divided by 4 would have been 1.25. So that would have been an alternate answer, but probably the better answer is 5/4. Is there any question before I go any further? Is this clearer to those who are having a hard time? Okay, great. Okay, great. I'm glad to hear that. Okay. I just would like to do an example that has decimals in it, just as a reminder as to how to do decimals. Oh, you know what? I think I'm not going to do the one with decimals now. I'm going to wait until you next lesson, because I hope by then most of you will have a calculator. When you have decimals or fractions, and we are going to do some examples with decimals and fractions, and there are going to be a lot of them, but we do have to know how to deal with them. I'd like you to be able to access your calculator when you're doing that. So let's do one more example. I'm gonna stop the class early because I want to spend a little time. If anybody wants to talk to me privately, then I'll stay on. So let's do one more example and then I'm gonna let you go. Seven X minus 3 times X minus 2 parentheses equals -4. Let me get rid of this over here. Times 5 minus X. Let's see what you could do with that one. It's similar to what we just did before.
Calls from Flushing and Y.
Nobody's giving me any answers yet. Excellent. Okay, I'll give you a couple more minutes and then we'll have to do it together. Okay, I think we should try and do this together. Seems like I just got one person giving me an answer. Seems like you're a little bit stumped. So let's see how we go about this. And of course, we're going to go about it exactly the way we did before. We're going to first remove all the parentheses, then we're going to get all the x's to one side, to the right side, to the left side, and all the numbers on the right side, and solve our question. Okay, so here we have 7x, nothing in front of it, we'll just bring it down. -3 in front of the parentheses gives me -3x, and -3 times -2 becomes +6 equals. Now we're going to multiply everything over here with -4. So we'll get -4 times 5 is -20. And -4 times -x. Again, this is like a -1 in front of here. A -4 times a -1 would give us +4x. Okay, now we've got to combine the like terms. So on this side, on this left side, we have 7x minus 3x, which gives us 4x plus 6. And on the other side, we have -20 plus 4x. All right, so we're now at the point where we've got to get all the x's to the left side, all the numbers to the right side. So I'm going to first get rid of this 4x on this right side. So I'm going to be -4x and -4x. And 4x minus 4x cancels out. So all I'm left with on the left side is 6. And on the right side, I have the -20. And this is very strange because what's happened is that we can't go any further because there are no x's left. The variable has totally disappeared. Now, there are two ways that this can happen. When the x's, after you clear everything out, if you simplify, after you combine all the like terms, if you're left with no variable in your equation, you have to look at what the statement is saying. Our statement is saying here 6 equals -20. Now notice it's not saying 6x, it's saying 6 equals -20. Now is that a true statement or is that a false statement? Does x equal -20? Obviously not. It's false. This doesn't make sense. Notice it's not a conditional statement. It doesn't have any variables in it. It doesn't have any x's in it. It's just saying something about numbers. It's something that's patently false. If it's false, that means there is no solution. Sometimes that's written with this a zero with a line through it. That's another way of writing no solution. I'm not going too low. Okay, so here's one situation. You go ahead and you're doing all the right things. You're solving your equation the way you've always solved your equations, except when you get to the end, you're left with no variable. If what you look at what you're left with, does the statement make sense or not? In this case, 6 equals -20 doesn't make sense. It's not a false statement. It's not a true statement, I'm sorry. It is a false statement. It doesn't make sense. So therefore, there can be no solution. In other words, our original statement was a faulty statement. It's impossible for this situation to arise. What's the other situation that could happen when you have your variables disappear? Let's say, let me give you another example, a little bit simpler. Suppose I gave you something like this. 3 times x plus 2 equals 3x plus 6. And I said, solve this. And of course, we go ahead and do it the way we did it before. Remove the parentheses, 3x plus 6 equals 3x plus 6. And then I want to get all the x's to one side. I think you're going to see what's happening already. So I'm going to minus 3x from both sides. And not only does the x's disappear from the right side, it disappears from the left side. And I'm left with just numbers. In this case, I'm left with 6 equals 6. Now, is that true or false? Obviously, that's true. 6 does equal 6. So then, your solution is any number. This is a statement that's true all the time. This is all real numbers. Is your solution. Every single number that you would use, pick x to be 1, pick x to be 2, pick x to be 0.777773. Whatever value you pick for x, this side will equal this side, because if you look at it originally, the statement is a statement of truth. It's true. It's not dependent on the value of x. So let's just review what we just it doesn't happen often. The situation where the variable disappears is an uncommon situation. But if it happens, there are 2 possibilities. Possibility number 1 is what we had before, where when the variable disappeared and we had 2 different numbers on each side of the equal sign. That's an impossible situation. There's no solution. But if you have the same situation occurring where all the variables disappear, you're left with no variable, no x at all. But what you're left with is the same number on both sides of the equation so that you have a true statement, then every single number, all real numbers are the solution. So that's what could happen, either no solution or everything's a solution, depending on whether you get a true statement or a false statement. Okay, does anybody have any questions? If not, let me just remind you, we meet Monday, Wednesday, Friday at 8:20 until 10. I know I'm dismissing you a few minutes early, but that's because a couple of things I want to stay on a few minutes to see if anybody has any questions they want to ask me without everybody in the class being there. Though everybody has the same questions, you really should ask in front of everybody because everybody will benefit. That's number one. Number two, I want you to make sure to go ahead and sign into Delta Math and take a look at, I think there should be an assignment that comes up. I'm going to make sure it's available for you right after this class. It might take a few minutes to come up, but make sure to sign in and try and do some of the examples as a review of what we did in class today. I will start the class with any questions on Monday, any questions that have to do with things that came up on that homework. If you have any homework questions, but again, I think you're going to find Delta Math a very positive. If they haven't ever used it, it's a nice way to do work. And I can check who's been on it. And I can see how many problems you've tried and how when you're doing homework, it doesn't matter how many you get wrong. It just means keep trying until you get them right. There is the class code. I'll put it on again, but it's definitely, if you want, it's listed on Blackboard, but here is the class code for Delta Math. 2 I can't even read my own handwriting. Oh, it is a U. UW5 Z 6E J. You will also see it, it's on Blackboard. If you look in the class lessons, can't remember exactly what it's called, but don't look just at it in the information page, but look at the weekly classes section, and all this information will be there. Make sure you sign up and try it. Again, I will post there's going to be a weekly a recording session on Blackboard, and all the recordings from the classes will be there. Okay. So I'm going to end class now. I'm going to end the recording.